How does DHCPv6 differ from DHCP4, IPv4 addressing? Imagine your network is a busy city, and every device needs a unique address to get around. Now, think about how the system assigns those addresses and configurations. That's where DHCP comes into play. But did you know that DHCP4, IPv4, and DHCPv6 work quite differently? Let's find out how. First, DHCP4 IPv4 assigns an IP address along with other details like subnet masks, default gateways, and DNS servers. It's a one-stop shop for network setup. It also keeps track of which device has which address, making it a stateful process. This means the server remembers all the leases it gives out and manages them carefully. In contrast, DHCPv6 does not give out subnet masks because IPv6 uses a fixed prefix length, usually called 64. Instead, devices get their subnet information from router advertisements, which are messages sent by routers. DHCPv6 can work into modes: stateful, where it assigns addresses and keeps track of them, or stateless, where it only provides other configuration details like DNS servers. This flexibility is a big change from IPv4. Another difference is how devices find DHCP servers. IPv4 uses broadcast messages, which send information to all devices on the network. This can cause a lot of traffic, especially on big networks. IPv6 replaces broadcasts with multicast messages, which target only specific devices or servers. This makes the network run smoother and faster. The protocols also differ in their ports. DHCP4 IPv4 uses UDP, ports 67 and 68, while DHCPv6 uses ports 547 and 546. These are like digital addresses that help the devices and servers communicate correctly. DHCP4 IPv4 often supports hostname options, letting devices tell the network what name they want to be called. DHCPv6 does not include hostname options, so hostname management is handled differently in IPv6 networks. Finally, setting up DHCPv4 is usually done on specific network interfaces, while DHCPv6 is often enabled on physical interfaces and needs less manual configuration. This is because IPv6 was designed to be more autonomous and easier to manage. All these differences reflected how IPv6 was built to be more scalable, efficient, and flexible. Using multicast instead of broadcast reduces unnecessary network traffic, which is vital for large networks like data centers or internet service providers. The reliance on router advertisements simplifies subnet management and allows devices to configure themselves more easily. In summary, DHCPv6 differs from DHCP4 IPv4 mainly because it uses multicast instead of broadcast, relies on router advertisements for subnet info, supports both stateful and stateless modes, and is designed with IPv6's larger address space in mind. These changes help the internet grow and operate more smoothly as networks become bigger and more complex.